Good morning everybody, and let us discuss about this surface roughness further in the lecture. In the last class we have seen that surface roughness play important role in the quality of the components, and we have seen three different components. One is the profile, another is the waviness, and the third one is the surface roughness. So, let us see then how these three parameters are affected by different process parameter. It may be the machine parameter or it may be the machine itself. So, let us continue in further discussion. So, this is the surface roughness profile which we have seen in the last class, and we have seen that it has three component. One is the profile component, it has a very long frequency component, waviness is the something which is medium frequency, and the roughness is a very short frequency component, right. So, let us see all the things. The one is the roughness. How the roughness comprise of the irregularities that occurs due to the mechanism of the material removal of the process. First thing is the tool geometry, wheel grit if it is a grinding process, and if it is a machining process then it is a EDM spark. So, now how this tool geometry will affect here, because we know that we have one something is called the nose radius, correct, and now let us consider that we are turning one workpiece, right. So, this is the workpiece and we are turning. So, we are rotating is in this direction. So, if you zoom this particular thing, what is going to happen, that we are moving this particular workpiece in this direction and we are tool in this direction, we are rotating workpiece in this anti-clockwise direction. So, if you zoom this particular area, what is going to happen, your tool is actually penetrating inside and this is your workpiece. Right. So, these are the features. So, these are the different condition of the or location of the tool with respect to time. It is going inside and inside. So, once you complete this machining, what you are getting? You are getting a small artifacts of the impression of the nose radius, whatever is there. That again depends on three parameters that we all know, that it is a cutting speed. Let me write it here. So, it is a RPM of the workpiece, because now here our workpiece RPM, because if it is milling operation then workpiece RPM is the tool RPM, then it is a feed rate and depth of cut, because now if you increase the depth of cut, what is going to happen, that your tool will penetrate more inside it and your waviness will be more. If your feed rate is very high, then what is going to happen, that you will get this type of impression. If your RPM is very high, what is going to happen, you will get a very small imprint, because high RPM and the low feed rate will give you the good surface finish. High RPM plus low feed rate equal to good surface finish, correct. So, you have to consider these particular things in such a way that you are getting a surface finish as low as possible, right. Then the wheel grit in the grinding operation. So, this is related to machining, this is related to the grinding, and this is related to the advanced machining process. So, that is called machining process, because here we know that if the spark size is very large, it will remove more material. So, it will create this type of crater, and if your spark energy is very low, at that time it will create a very small crater. If it is a very high, then it will create this particular thing. Grid size is also important. What is the grid size? What is the spacing available between these two? Because if you have a grid size something like this, and if you have grid size something like this, then here your roughness will be very low roughness, because surface finish should be very low and surface roughness surface finish should be very high and surface roughness should be very low. So, if it is the grit size of this one, then it will penetrate more also, and at that time it will damage or it will create more material removal. More material removal means more surface roughness, right. So, these are the three different processes by which you can create a different roughness, and everything depends on this particular part. So, this is about the roughness part. Now, coming to the same operation, but it is waviness. Now, what is going to happen with the waviness? So, component of the surface texture upon which the roughness is superimposed and resulting from the factor that we will see now. So, now what is the roughness? Roughness is, waviness is the component on where the roughness is superimposed. So, roughness is located here, right. So, roughness is superimposed over the waviness. So, that is the way, then you reduce that waviness, then you will get the same thing here at this location. So, what are the components which will affect of this part? This is the machine part deflection. Now, what will happen that if you have workpiece here, again same thing let us discuss, turning operation, and you have a problem with the holding this component. So, it has some deflection at this location, at this location. So, what will happen that this will vibrate with a very high frequency, but very low amplitude, right. So, it will not be something like this, but it will be also not like this, it is something in between these two. So, when this will vibrate, what is going to happen, that you will get some type of this is the vibration, right. So, this is the total span of vibration and your tool is located here. So, this is your cutting tool. So, when it will vibrate, then what is going to happen, that your workpiece is something like this. So, it has some this type of components, and on the top you have a vibration also, that means roughness component also, that is obviously by the cutting tool action. So, because of these particular things, you are getting a different one under signature other than the profile and the roughness, that is called the waviness. Then vibration, the chatter, that is also one of the thing that you are, suppose you do not have any deflection from that part, but you are end up with the chatter and vibration because of many different reasons. So, that will also create a waviness on the surface, and the material strain, because if your material is very strained, then what is going to happen, that you will get more elongated profile on the waviness direction, and on the top of that you are getting a surface roughness of the parts. So, this is about the waviness component. And third one is the profile component. So, this is the profile. So, what is that? The profile is a overall shape of the surface ignoring the roughness and waviness variation. So, it is mostly caused by the tool slide, machine tool slide, because this is very long wave. So, you cannot get the same thing by this type of roughness or not by the waviness also. Now, consider that we have seen that geometric errors. Geometric errors in x, y, z and rotation, that is c axis. We have seen some animation where your movement was in the x direction, but you are getting a rotation in the y direction, translation in the y direction, rotation in the z direction, the translation in x z direction. So, those are the geometric error. So, what are those things? That suppose your tool is moving with the tool post in this direction, right. So, it should be completely straight and your workpiece is here. So, this is your workpiece, correct. So, now what is going to happen, that suppose your tool is not that means your slide is not completely straight, then what is going to happen, that suppose your slide is something like this, correct. So, what is going, the tool will actually move in this direction. So, instead of a straight cutting, or what you are getting here, you are getting something like a taper cutter. So, this is the surface which you are going to get, because your tool is moving in this direction. So, this is your tool motion, but your actual tool motion should be in the straight line. So, this is very long variation or the long frequency component, this is happens because of the error or the geometric error of the machine tool slide way or the axis orthogonality. So, those are things called the geometric errors. So, these are the three different profiles. Now, what is our objective? Our objective is to reduce these particular things. If you are machining with a straight surface, then the profile should be completely straight, that is also we do not want, and we also do not want these particular things in this part, right. So, these two things we can achieve here, but roughness is actually the stochastic. It is very random in this case that you are not able to control. So, you will not get a straight line of the roughness. If you increase the magnification of any surface at a small scale, then you will get the roughness profile anyhow, because this is very difficult to get, or it is almost impossible to get the surface roughness in a straight line. But this particular thing we consider as a perfect surface if it is fulfilling our requirement, because if you see the optical materials, that optical materials when the light passes through it, if it is a mirror then it will translate, and if it is a lens then it will pass through it. So, if the roughness is low to the whatever the lowest possible way, then or homogeneity of the light which is passing through or which is translated from the surface of the lens optical material, then it will have a very perfectly required dimension, but that will depend on this particular surface roughness. So, smaller the roughness, better is the performance in many cases, but it is not always to many cases you always need a surface roughness also. So, that is different case. Right. So, what are the, now let us go more detail about the roughness only, let us not talk about the waviness and the profile, because those two things can be actually controlled by the different ways. If you remove all the variation or the errors from the machine tools and the other parts, you can actually maintain the waviness and the profile, but roughness is very difficult to control. So, let us now concentrate only on the surface roughness. So, what are the things that this is the one of the profiles which we can get by the different instruments. So, this is measured by a contact profiler or the non-contact profiler. So, what we are looking at this particular part is the 2 or 3 different things. So, one thing is the height. So, these are the roughness and this is the 0 line. So, that is called the mean line, correct, and some part is above the mean line, some part is below the mean line. So, now what is the height, that how much is the height of these peaks from the mean line. So, that is called also from the center line. Second thing is the depth. So, how much is this depth, correct. So, these are the depth. These two important thing is there, and third important thing is what is the interval between these two, correct. So, these are the 3 different parameters of a roughness profile which play very important role in the performance of the component. So, size and the shape of irregularities on the machine surface have major impact on the quality and the performance of that surface. Now, how this thing will behave? Now, suppose you consider that you have a surface which has only height. Consider this is the one surface, correct, and now on the top of that you have one surface which is in relative motion. So, this is moving in this direction, this is stationary, consider this is stationary. Now, this is at microscopical, we are not talking about at a very large scale, it is very small peaks, and now when you are moving this surface here and there, what is going to happen? This is actually the actual contact area, that is called apparent contact area. But at macro scale, what you think that your whole surface is in contact with this particular surface, but that is not the correct thing. So, these particular peaks are very small and they are very sharp also. So, let me write it sharp and small. Sharp and small peaks. So, when they will move in this direction, what is going to happen? This will shear off from this part. So, its wear will be very high. So, it is wear rate is very high. Very high, right. So, height will play important role. Now, take the same surface. Now, let us just reverse it. Right. So, we have not done anything, just reverse the surface and let us put the same component on the top. So, this is the same component, and again we are moving in both the directions. Now, what is going to happen? Now, what is our apparent contact area? So, these are our contact area, correct. So, our contact area is very, very large and they are also not sharp. So, your wear rate will be very, very low wear in this particular case. Other important thing or advantage of this thing, that if you consider a piston and cylinder mechanism. So, this is the piston and this is the cylinder. Right. So, this is the cylinder and this is the piston. Let me give different color. Piston, correct, and this piston is moving up and down. Now, if you consider this is the surface of this particular, because now interface is this location, right. So, this is the interface surface. So, this is the interface surface, correct. If this interface surface is something like this, then wear rate will be very, very high, and after some time what will happen, that you will have some type of opening between these two particular, it will not be a completely smooth fit, there will be some type of opening between these two. So, your cylindrical surface will be like this, that means your piston, and then your cylinder will be something like it is, means we are giving a very, very large magnified view in this case. So, after this wear, what is going to happen? This is going to happen in this case. Other than that, you always need a lubrication, correct. So, when it is moving up and down, you fill up with this oils here, and then this oil will be spreaded on this particular surface. And if you use this particular surface here, then there are a lot of advantages, because one thing is that contact area is large. So, you will not get this particular thing. Another thing, that there whatever this part is here, or whatever these valleys are here, these valleys are filled with the oil. So, your friction will be very, very low in this case. So, this particular pattern whatever is there, it will actually have the lubrication retention property. Lubrication retention ability, correct. So, here lubrication will be stayed here, and when it is moving up and down, it will also provide one type of less friction in this case. So, what we need this type of engineered surface, and these surfaces are not correct way of doing this thing. So, this is about the height and depth. Coming to the interval, how interval play important role? Now, consider that we have one surface is something like this, correct. So, this is the total height and this is the center line. So, consider the height and the surface, or height and depth both are same. Now, this is the one thing, let us consider the same thing, but it is at this level, again the same thing is here. So, this is the part of this part. Now, how this thing will play important role here? Now, it has a many things. Now, if you consider something like that, hydrophobicity and hydrophilic surface. Correct. So, now what is happening here, that you put a water drop on the top surface of this. Now, this is the water drop, what will happen, the water drop will actually spill and cover all the things, this will be completely filled with the water drop. So, this is water drop. If you put the water drop here, what will happen, the water drop will stay on the surface. Why it is like that? Because now what happened, that if you see it, if you have seen the lotus effect, so that is called lotus effect. If you see any leaf, what happened, if you have seen in the monsoon, there are lot of drops which are staying on the surface, and if you just incline or tilt this part, the water droplet will drop from the surface, it will not stay on the surface. Why it is like that? Because if you magnify this particular profile of this leaf, then what is happen here, that on the brief profile there are lot of small fibers which are projected from the surface, and it will actually levitate this whole drop of the water, and it will not spread the surface on the top surface, right. So, these are the advantage, that if you have a very high frequency component here and very low frequency component here, then spreading of the water or any other things which will play important role. Suppose you are using some component, some surface here, and you are putting some drops here, chemical, oil, whatever is there. If you have surface something like this, then what will happen, this particular drop will actually slide completely and nothing will stay on the surface. But if this is the condition, that you have a large frequency component, small frequency component, and then you are putting the drop will stay here only, it will not slide completely, right. So, there are different, this is one of the applications only I am discussing, but there, other than that there are many applications where if you do not change the height and depth, but you change the interval, then it will, the surface will behave differently in different conditions, right. So, differences in these irregularities impact the quality and function of these surfaces. So, what is the friction? What we have seen earlier, that friction is very high if your height is very high and you do not have plateau surface. Durability is also important, because if the roughness is very high, your wear rate will be very high. Wear part is that, then whatever the particles which are worn from this surface, whatever these particles are worn, that will stay here, and then what is going to happen, that it will create further wear or the accelerated wear of these particular asperities, because now these are considered as a foreign particles, and these particles you very difficult to remove, because now sometimes it will fill up this gap and it will reduce the all retention properties also. Operating noise is also very high, because you know when the two smooth surfaces are in contact, you will not get voice, but when there are two rough surfaces are in contact and then they are moving, then you will get more noise. Energy consumption is very high, because we know that if you are sliding one component on the surface, smooth surface, then it is very easy to slide from the surface, you do not require more force here, but it is on rough component, F is very small, and rough component F is high, and smooth component F is low, because you do not, it will slide very slowly. And air tightness is important, because many location you do not require the air to flow from this, because there is mostly a gasket type of things where you do not want to leakage also. Air tightness is one thing, leakage is another thing. So, at that time all these things, roughness, height, depth and the interval all play important role in this type of different characteristics of the component. Right. So, what are the instruments we can use for those things? So, there are many instruments. One is called the stylus type, another one is optical type, and this is called atomic force microscopy. So, let us see this thing, this is called atomic force microscopy. So, here it is written wavelength, and on this particular diagram it is called amplitude. So, what are this wavelength and amplitude? So, this is what is that thing. So, this is the surface wavelength and this is called surface amplitude. Stylus type, that means what is, we are not going to discuss this component, because this we will cover at the end of this particular two processes, micro machining process and precision machining process. If time permits, we will cover this process in detail, but right now let us discuss in a very shallow way. So, this stylus way, that means you have one stylus and you have one surface, right. So, stylus will move on this particular surface. So, stylus is moving from here and then it is reaching this location, then reaching this location at this location, and because of that what will happen, the stylus will actually vibrate in this direction, in this way, that way, and because of this vibration what is going to happen, there is one coil available and this particular core is moving up and down because of this vibration, and whatever is the up and down is this motion, this is the coil. So, this distance will continuously change, it will create one voltage signal. So, depending on this up and down motion, you will get a same signal in terms of voltage. So, then you have a analog to digital converter or digital to analog converter. So, that you can convert this particular mechanical motion, that is analog signal, to the digital signal. So, you need a ADC converter. So, ADC converter will convert this thing, it will amplify, also amplifier is available, and finally, the same thing will be plotted onto the graph or in your computer screen. So, this is called contact type, your stylus is moving on the top surface. Optical, that means you do not have physical contact with the sample, you have a light and then you have a one particular lens, and this particular light will strike to the surface, and then there are some receiver of this light. So, what is going to happen, that suppose you have waviness and then light is passing here, and then you have a one particular receiver. So, when if you have flat surface, then what is going to happen, this angle and these angles are same, and if you have a waviness here, then these angles are different. So, this particular location will be different at different locations, and this way you can optically measure the roughness. Other way, that there are many optical, there are many different methods available. If you talk about the optical microscopy only, then what it will do, that suppose you have this surface, then it will scan the surface in this way. Every time it will scan, your area will be increased, and finally, it will stack up this particular surface, then it will create a 3D surface measurement. So, that is one of the advantage of going with the optical and AFM, that you will get the 3D surface compared to stylus. Stylus, what you will get? You will get one line roughness only. But if you get a many lines roughness and then you coupled or stack with each other, then you can get a 3D surface. All these instruments have a different advantages and disadvantages. Now, coming to AFM, AFM you can see that AFM is very better, or it will perform much better in this particular range, because in a small scale, if you see the nanometer scale, AFM is more advantage of using at this particular, because it has a wavelength also in nanometer range and amplitude also in nanometer range. How this thing is important? Because now we see that if you have a surface something like this, correct, and if you are using with a stylus with a radius of something like this, then what is going to happen, that this stylus will simply move on the surface, because it is not able to penetrate inside the surface. So, what you are getting the graph, you are getting a graph something like this, or you will get a graph of something like this. In optical also, what is going to happen, the what wavelength you are using, white light you are using, white light interferometry, or you are using green light, that everything depends on that. At that time also, that performance of this particular, this is the stylus part. If you go with the optical part, then what is going to happen, you may get something like this, that is mostly it will cover the top surface, correct. So, that is what is going to happen here. If you go with AFM, AFM also one type of contact type or the non-contact type, depending on the mode which we are using. Frequency mode is there, tapping mode is there, contact modes are there. So, here what is going to happen, that mostly it will give some more realistic idea, because here the contact point of this particular AFM tip is very small and very sharp also, and it has a very high amplitude load amplitude variation measurement capability, and the wavelength is also very less. So, this is more actually connected with this particular part. So, how you have to decide those things? The one is the working capability of the instrument, how first finally you have to decide which instrument is used for that. Resolution is important, what is the smallest measurement you can use for that. So, optical and the AFMs are more better in the measurement of the micro components, micro component, good for micro components, correct. That vertical and the lateral range, that means we have seen that what we want to measure height and depth only, or we want to measure the spacing or the difference between the two heights also. Probe geometry, because smaller the probe geometry, more realistic things you can capture by that. Scanning mechanism, because we know optical, there are many confocal microscopy is there, then interferometric based optical measurements are there. So, those are the different mechanism by which you can get the different type of results. And there are other constraints, that what are the temperature requirement, because in stylus mostly you do not need a lot of temperature sensitive things, but optical and AFM you have to maintain the temperature also, because most of the things it are based on the laser type of things. So, those things are very important. So, these are the different ways you can select the component, but mostly people prefer optical and the AFM measurement for the micro component surface roughness measurement. So, let me finish this class here and we will continue this further discussion in the next class. Thank you very much.